Our first presentation this evening is Learning CAD with Onshape, presented by Anonobots. Please use the chat on Twitch to ask them questions. Thanks. Take it away.
Hi, I'm Riley with the Anonobots, and I'm super excited to present our first ever kickoff panel to you guys. Today, we're going to be talking about how to use Onshape for FTC, a little bit about what CAD software is, and why we recommend Onshape to teams that are starting out. This is my brother, Cabot.
I'm Tuan.
And we're going to start out by explaining to you just a little bit about what CAD software is. So CAD software in general allows you to create 3D models. So you can create parts, and you can assemble those parts into what are called assemblies, which allow you to take a look at how your robot's going to be put together even before you build it. Saves you time, saves you money, and it allows you to create custom parts. So there's a lot of great things about it. Now, we're going to recommend Onshape to rookie teams, and this is what we've used for the past 2 years. And one thing that's really great about it is it's similar to the Google Suite in the sense that you all create online accounts, and then you're able to interact live with each other on documents, and you don't need to install any software. It's all based in your web browser. Make sure you create an education account when you're creating your account, so you can have private parts and you don't have to make everything public. So we made up a game that we're going to be making our robot for. We decided that let's pretend our game is a game where you have to intake and shoot 3-inch balls. So we're going to be using the Go Build a Strafer chassis, which some of you are probably familiar with. And that's something we'd recommend to rookie teams because it's a really easy way to get started out building your robot from a good solid drive base. We're not doing any of the indexing or sorting of the balls and shooting of the balls in this design, just the intaking for time reasons. You'll notice that we don't have the best naming conventions in our files during this video because we just did it for a demonstration. We'd recommend coming up with a good naming convention for your files that you stick to throughout the season. So that way it's really clear whether it's something's a part, whether it's an assembly, what revision you're on, and what that part is before you open it up. That really helps you out. And the custom parts that we're making in this video, you could achieve a similar result using off-the-shelf parts from Rev and other companies. But the reason we're recommending that you use custom parts is because you get more flexibility and it allows us to teach you how to use Onshape. So we cut up about 1.5 hours worth of CAD into 30 minutes here. So this is going to move fast. And the reason we did that is because we wanted to show you as much about creating parts, assemblies, and the basics of Onshape as we could in the 30 minutes that we have here. So we're going to post this to our YouTube channel later today or tomorrow, in nice 4K, so you can follow along and learn along with it. Because that's what we've found is the best way to learn CAD is to follow along with videos, follow along with tutorials, and do the same thing they're doing. That's been instrumental for all of us learning CAD. Feel free to ask questions during the presentation in the Twitch chat. And if you're watching this after this presentation's been live, feel free to comment on our video or send us an email if you have any more questions. So without further ado, we're going to get to our first video.
This is the Go Build a Strafer chassis. This is a great starter drive base that we recommend to most rookie teams. You can download it at Go Build's website. Almost all parts you'll buy in FTC will have downloadable files on their website. It will be downloaded as a zip file, so you'll need to unzip it before we can upload it. We'll then upload the step file, which is a universal file extension for 3D files. Once it finishes uploading, it'll take a while to import the files. It isn't a problem with your computer. Once you are done, you will want to go to the final assembly. This is the one that we will be working with. This is a motor.
So now we're going to jump right into a video on creating our first part in Onshape. And feel free to ask any questions if you have them as we go along, and we'll answer those once we're done with the video here.
This is a motor from Rev Robotics. It's a 20:1 planetary motor, HD hex. You can download it at their website. Once you have downloaded the motor, you will need to import the motor file into the assembly we created earlier so that we can measure the parts of the motor and import it into our strafer assembly later. So here I am measuring the distance between these two holes When you click on two different sections, it will automatically measure the center distance between the holes. And then if you go down to the measuring icon in the bottom right, it'll give you more information, such as minimum distance, maximum distance. And if you just click on one, it'll give you the length or the diameter. So here you see it's 2.2 about. Here I'm going to click on a plane and press the sketch button up there, or you can do Shift S, and then I just clicked on the front to rearrange it, and there in the left hand corner I clicked on rectangle. There are two types, center and corner. It depends how you make them. There I did circle, so that's button C. So I just placed those down, and I made this horizontal by clicking on the center points of those and pressing H. I now just copy and pasted the number from beforehand and put that for the spacing between those circles so that they are the same length apart, so that they will match up and they can be constrained together. I then dimension this to 3. I forgot to mention how you dimension is you press D, and then you click on two spots, and then they're dimensioned. Here I'm making two construction lines. Construction lines are lines that reference, and they will affect the sketch, but they will not show up on your final product. Here I'm making them equal. You either press E or you press at the end of that search bar, there are a bunch of constraints. You press the equal one. I just press E because I like shortcuts. Here I need to measure the center distance between the center of the circle and the bottom of the strafer. That was 3.14. So I'm going to measure from that center point to the bottom of this rectangle. So now is that far, so these will match up with the bottom corner of your strafer. Okay, so now I need to measure the radius of this clamp, so we can put the hole in the plate. So here it says about 0.315, so double that for it. But since you also see that screw there, that goes past it. So I'm gonna try 0.75 and see how that goes, and then I can always edit that later. Just remember, for dimensioning, you press D, and then you click on it, and then you just have to type in a number. So here I'm measuring the distance between different circles. So the blue line is the vertical distance, and the green line is the horizontal distance. So this is what we will be dimensioning it off of. So this is like 0.6299. So I will click on the center of each of these circles because that's where I dimensioned from. And see it copied in a negative, just take off the negative. So here will be the horizontal distance, which will be 1.57. So that's how far to the left it will be. Again, click on the center points. Make sure it's not at the diagonal or to the right. It depends how it's positioned, how it dimensions it. So now I need to measure the diameter of the circle, 1.57, which is the size of a number 6 screw. So I'll type that in. And as I pointed out before, I had those circles equaled, so they both shrunk down. So now I need to add 2 more circles above those circles, so that's 1.259, I think. So I just hovered over the center of that circle and placed it. That is just an automatic vertical thing, but you need to hover over the point. So you see how there's just 2 lines there? Because I hovered over both of those centers. So now they're automatically vertical and horizontal constraint to each other. And I just clicked on 2 new circles and the old other circle and pressed equal or E, and now they're the same size. Okay, so now I need to dimension these vertically from each other. So I will paste in that number. Now these holes will line up with the ones on the strafer kit. Now I'm going to shrink down this top part because it doesn't need to be this tall for this mounting part. So I'm just going to measure the height of this, which is 1.889. So I'll use the dimension tool. I'll paste in that number. And now this is all dimensioned. So now I'm going to turn this top line into a construction line. You just press Q to do that. You can do it before or after when you're making it. Now I'm going to add 3 more lines on top. And you see I hovered over that line, so now it does the automatic vertical constraint. So the reason I'm doing this is because the bottom part is just for mounting. Now this is the part that holds the motor and the hex shaft that will be driving our intake and bringing the balls. Now I'm placing down some more circles. I did the vertical and horizontal automatic constraints there. So 1.102. The holes I just put down are the same ones as on that rev motor, because this is where it will be mounting into the plate. Now I'm gonna put in some construction lines to dimension these the right length. So I'm gonna dimension out both of these. You could use equals, but I decided not to. Now I just put a point in there. In the middle of it, it hovered like a little yellow box. Then you click on there, so that's how you know it's in the middle. And then I clicked on that point and on the other line. Then I use the midpoint constraint. The midpoint constraint is used so it will go directly in the middle of both because I did that point. So now it is perfectly symmetrical. Then I equaled all the circles and dimensioned them. I'll dimension them to 0.098425 because that's the size of the rev screws. So now I need to put a hole in the middle. So here I have the size of the hex bearing that's needed, and it's the outside diameter is 1.125. So now I will put a circle of that directly below. Use the auto vertical. That's one of my favorite constraints. I don't know how far down it'll be yet, so I time constrained it. And this is the whole first part out where the shaft comes out of the rev motor. So I just put in that circle plus a little bit tolerance. So here I'm going to model in the 2-inch compliant wheels. I think that'll be a good size, but we might have to end up changing that later. I'm doing construction circle because this actually isn't going to be a hole in there. It's just so that we can visually see where things could possibly overlap, so we can avoid that. So I just measured the size of the motor, and I'm going to put in another construction circle. Remember, you can just press Q, and then it won't actually make another hole in your part. So here, as you can see, they don't overlap, but it's pretty close, so we might want to change that later. That's center distance, not minimum. That's some good clearance. So we realized that this bracket would actually be too far up off of the ground, so we are going to need to change this 2-inch to a 4-inch wheel, and we will need to bring this bearing up an inch. So as you can see in the bottom set of circles, the one that has a solid line, so that will be the bearing hole that's overlapping with the construction line, which means that it would be going into the strafer chassis, which we don't want. We want it to be above it. So we're going to bump up the size of the wheel by 2 inches. It can still interact with the 3-inch balls that we're going to be using in this example, but it also won't go into the strafer chassis. You see the 1.859 dimension on the side? That is the distance between the bearing, which will have the hex shaft on it, and the rev motor. But as you can see, that 4-inch construction circle overlaps with the motor's construction circle. So we are going to need to bring up the rev motor. So I'm just going to bump that up to 2.85 for now. So just that it doesn't overlap. Here is our sprocket distance calculator. As you can see on the bottom, there's a drive sprocket teeth and a driven sprocket teeth. Those are the amount of teeth that we have on each of those sprockets. So we enter those in 1016. So now I'm going to enter in our approximated center distance. So it's 2.85. Then press compute, and on the side it gave us 35.87 links. So it has to be an even number. Up there, I put in 36. So you can round up or round down. I rounded up. Then I take the number that I outputted and I put that in. So we have a properly tensioned chain. So there's no slack. So now I'll just make sure that this plate embodies all of our parts. So now we're going to extrude our part. You can either do Shift E and it will just do it out of the sketch, or in the upper left hand corner, you see the box within a box thing. That's the extrude. So this will make our part 3D. So the depth is the thickness of it. So we want 0.25 for this because that is the thickness of the bearings. So now we got our finished part.
My apologies. That was the start of how to create our first part in Onshape, and we had a few questions come in while we were running that video, so we're going to answer those now. The first one is Onshape free? And yes, Onshape is free to everybody to use if they want to make their parts public and not for commercial use. But because we're all students here, we're able to get an education account with Onshape, which allows us to make private parts that aren't for commercial use, which is what we all use on our team for our Onshape parts. And you're able to share stuff, just kind of like Google Drive with that, but through Onshape's network. You make great private parts for free. Another question we got is if you wanted to start an FTC team, didn't have any prior experience with CAD, how long would it take you to get familiar with it? And you want to take that, Kevin?
Yeah, so for me, to learn everything, I'd say like 4 to 5 like semi-complex parts, but for it to become like second nature, so you can just remember all their shortcuts, everything like that, about 1 whole robot.
So kind of the more practice you get, the faster you'll be.
Yeah.
And our first season, we did not have, we weren't modeling nearly as much stuff as we are now. And that's how most people will start out. They start out not modeling as much stuff and you'll learn as you go. As you start to need to model more complex parts, you'll learn the new features that you need to be able to get that done. So now we're going to take a look at our final video on working with assemblies and creating our other part.
So now I'm going to duplicate this part, and for the other side, we're not gonna have 2 motors, so we don't need to have the motor on the top. I'm just gonna draw a line through the middle of this. Then I'll dimension this, do that, make it 2 inches above there. Chop off this top part because we don't need this in the copy. I'll deselect that. If I delete now, it'll delete those whole lines. So now I'm gonna show you this great tool called the trim tool. You just press T or you click on the scissors icon and it will chop off anything after a certain point. So because I had that line there, it chopped it off. Now we completed our secondary intake plate. Here is the assembly section. This is a little complicated, so we have to insert parts from other documents. So you click the insert button, the other documents button, then you click on the breakout session mount. Well, whatever you called yours, that's what I called mine. So then you have to create a version. Then you want to take your intake plate and your secondary intake plate. So we'll paste those in and then click on that check mark. So on the right, you'll want to use the one that has the motor. You don't have to, that's just what I did. So you have to click on that mate button. So you click on these 2 points, and as you can see, they are occupying the same space currently. So you want to flip that arrow, it flips on the primary axis, and then it's actually not positioned right, so you have to reorient on the secondary axis using the clockwise thing. So now, as you can see, that screw is intersecting our plate. So as I said earlier, we can just go into the other part and edit it. We'll have to edit it on both. You right click on the sketch, you click edit, or use double click. So let's change it to 0.8, see if that works. Change it on both. So you type in the 0.8 again. Then in the upper left hand corner next to the name, it says create version. So you want to do another version, press create, you go back over to your other tab. Then down there, see that little blue icon. You want to click on that and then you click on update link document. So then once it's updated, as you can see, that no longer intersects. So it'll be all nice. Now I'll need to constrain the other plate. So now I'll click on this hole and I'll click on that hole and this bottom corner hole. Then as you see it's mesh, so you click the flip or the axis. Then you reorient the second axis until it's in the right spot. And now all the holes are lined up. So now we just need to insert bearings, some sprockets, the motor, the hex shaft, and the wheels. Actually a lot less complicated than it sounds. So this is where I kept the motor. You have to go into the plus icon in the bottom left hand corner, press import, then you click on the file, insert it. It will take a little bit to import, but not as long as it's straight for chassis, so that's good. Okay, so it's in. As you can see, it's the exact same as the other one. So then you insert, and then you have to click on assemblies, because an assembly, not a part. Then just search for rev, and click on that, and then you click insert. Just so you know, when things first get put in, they are not grouped together in any way, shape, or form. So what you gotta do is you gotta hover over all of them, select them, then you got to click on this icon called group. So now they'll all move around together. It's not the cleanest way to do it, but it's easier than making them all. The chassis is also not all grouped together, so I'll just group together real quick so it doesn't move around us. So this is Revolute Mate. Revolute Mate makes it so that you can rotate what is mated. It can turn a full 360 degrees, or you can limit it for how far it turns. Here we're just gonna do a 360 limit. Now we need to import the bearings. So we want a 1/2 inch hex, 1.125 outer diameter. I select this and do Control F. Then I go down to CAD files and then I click down and then click download. So now we need to import it. So go into wherever's downloaded, click on it, click open. Then you wait for it to import. It's not that big, so it takes not that long. This is a part studio. You just click on it and then you can insert as many times as you want. We just need it twice. So for this, we just want to use Fascinate. It isn't anything special. It's just putting face to a face or edge to a face. Basically, it just can't move. So we'll do it with this bearing and also the other bearing. Now we're measuring from the farthest out parts of the bearing because we need to make a custom design hex shaft. You can just buy a longer one and cut it off. I'm just doing this for the part. Now I'm going to make a new part studio. I'm going to make a custom hex shaft. We need to design the hex pattern. Doesn't really matter which one you use because we're going to be dimensioning it in a different way. So I'll bring it down to 6. And then as you can see, it's 0.5. So we'll just take a dimension and click on both sides. And now it is a 1/2 inch hex. So now let's do the Shift D again. We'll paste in that number, but we also want to have 3/4 of an inch on each side for clamps and sprockets. So plus 1.5. In Onshape, you have to have parentheses on each side, so otherwise it doesn't realize that's an equation. So now it'll work, and we can just insert this into the assembly. So here's a fun trick with mates. So you can just click on this edge and then you click on this face. Okay, so the fun trick is you need to be even on both sides. So it's sticking out 1.5 on one side and none on the other. So you just go into the offset and then you offset it by however much you need. So this is just by 0.75 and then voila. So now we need to insert the sprockets. So this is the 16 tooth one, which will go onto our hex shaft. So we'll insert that. Just remember, if you can't find it, just make sure that you import it before you try to look for insert. If that doesn't work, check in both part studios and assemblies. So now we want to Fascinate. Make sure that hovers over the center hole. And this one. So now we're going to need to insert the 10-tooth sprocket, which is the one that's powered by the rev motor. This one has a set screw in it, so it doesn't need to be on a flat surface. So for the offset in this, we're gonna constrain the sprocket to the face of this rev motor. As you can see, that's not in the right spot. We need to make sure that the faces of each sprocket are level with each other. So since we measure that parallel distance, we can just insert the right number and then it will be equal to each other. So now we're gonna need to insert the compliant wheels. So you download this file. So now we'll insert it. Okay, so now that we have imported this, we need to select all of this and group it so that they don't get messed up like the other one. So now we need to insert the wheel. Okay, so we are going to need 3 of these. Now here's something that I like to call math time with Cabot. So as you can see, these are 1 inch in width and this is 8.94 inch parallel distance. So we take the 8.94 parallel distance, we subtract 3, 1 inch per wheel, we subtract that, then we divide that number by 4, so we have 4 equidistant spaces in between, and that's how big the offset should be in between each wheel. So as you can see, it's merged, so you just flip the primary axis, and then you insert that number, and then you got wheel. Now we're going to repeat that for the rest of the wheels. and here we are. Thank you for joining me today, and I hope you learned some good tips and tricks for the next time you're creating some parts and assemblies in Onshape.
All right, so now we're going to be going to questions. We had some more questions come in during the video, and we'll answer those here. And feel free to keep sending in questions until the end of this breakout session. One person asked, how do you get an Onshape education license? And you just go to Onshape's homepage. It's right there. You just put in the school that you're affiliated with, and you're done. Now you have an education license. One other person said that when they use Onshape, it's really slow. It can take a long time to respond. Do we have any tips for making it go faster? Unfortunately, almost all CAD softwares sometimes take a while to respond. If you have a really slow internet connection, that can affect Onshape more than other softwares because it has to stream data from the internet because it's all based in the web browser. But the speed of Onshape doesn't vary a whole lot from computer to computer as long as you have a good internet connection.
One main thing it does, if you don't have as good of a computer, when you're doing much bigger assemblies, it does take a very long time to load and to change things. I've had problems with that in the past.
Yep. So like when you get to the big, like our whole robot assembly will take, maybe 60 seconds to load an Onshape and 50 seconds to load if we load it in SolidWorks, which is another CAD software that runs on your computer. So you'll find long load times and wait times in a lot of CAD software when you start to get into more complex parts. And then I think that was all of the questions so far. If anybody has any other questions, you can send those in, and I'm going to put up contact information for our team right now. So that way you can reach out to us if you have any more questions. And so you can view our YouTube link when we post it later if you want to go back and continue to, if you want to work along with this video to teach yourself more about Onshape. One person asked, have we used other CAD programs? Yes, we have. So we used Onshape completely for our first 2 years. And this year we're moving to using more SolidWorks than we are Onshape. We still recommend SolidWorks to most teams because it's the easiest to get, we still recommend Onshape to most teams because it's the easiest to get started with. We personally switched to SolidWorks because we're starting to get into more complex things that Onshape doesn't necessarily offer, and because it allows us a little more flexibility. But Onshape, honestly, we could still use Onshape this season if we wanted to. It's a lot of its personal preference as well. But one thing that's good about Onshape over SolidWorks, especially if you're a school team, you can install the SolidWorks academic licenses that you get because you're as a first team, you can install those on school devices, whereas you can use Onshape on a school computer with a web browser or Chromebook, for example.
Also, this is just really good. One more thing that's really good about Onshape is you can collaborate real time in Onshape. For SolidWorks, you cannot. It's one person at a time.
Basically, all their CAD programs, you don't get that real-time collaboration, which is almost similar to the Google Suite. In terms of how you can real-time edit a document together, you can do a similar thing with parts and assemblies in Onshape, which is really powerful, especially when your teams are working remotely. I will wait to see if we have any more questions come in here in our last minute and a half. Just again, we know that this was a lot of video or a lot of content to pack into a 30-minute video, but we wanted to provide you guys with the most useful Onshape tutorial that we could. And we really do recommend, if you're serious about learning more about Onshape and you want to get started, to go take a look at this video later on, because you're able to follow along, and that's how we've found has been the best way to learn CAD.
So there's another question here. It's, what mate tool do you prefer to use? It's not my preference, but the one that you should use most often, if you just want just to be face-to-face, nothing turning, nothing moving, you just use the classic fasten mate. If you want to be turning, then you choose Revolute. Slider makes it so that it will go back and forth.
Yep.
There's some other ones. Those are the main ones I use though. So.
Yeah, we didn't get into it today, but you're able to, if you properly constrain things, you're able to add motion into your assembly. So you can see how your whole drive mechanism is going to turn, or how your shooter is going to work, for example. And you can see that all in CAD, but we just weren't able to get into that today. That's a little more advanced topic.
One more little thing while we wait for more questions is, if you have two things that are on Revolute mates, you can select both of them and then have them as like gear. So you can put in the ratio that they would be meshing as, and then they will turn together if you turn one.
All right, so that is going to conclude our kickoff panel for tonight. We're just at time here. Thank you all for joining us today, and I hope you learned some very some new tips and tricks about Onshape and about CAD software in general. And make sure you stick around for some other great panels tonight. Thanks.
Thank you, Anonobots, for that great presentation.